All right, in this video, we're going to do a couple normal model review problems. Some of these questions kids do struggle with a little bit, so this video is going to give you three pretty nice examples that kind of go from easy, medium to a little bit more difficult to help you understand how to work with the normal model. All right, this whole video is going to deal with sea turtles. So the adult weight of green sea turtles approximately follows a normal distribution with the mean of 330 pounds and a standard deviation of 30 pounds. So our symbols there are going to be mu is 330 pounds, and our standard deviation sigma is 30 pounds. All right, what proportion of green sea turtles weigh at least 357 pounds? All right, before we begin this problem, we first have to make sure we know how to write down the notation for what it asks us. So we're looking for the proportion, which could also be percentage or probability. It's all the same thing. So what proportion of green sea turtles, so I'll use a G for green, are at least. Now, at least means 357 or more, so greater than or equal to 357. Now, it is important to note that the normal model does not distinguish between greater than or greater than equal to. So whether that little or equal to line is there or not, it's not going to matter. All right, so this is just a notation for what we're looking for. We're looking for the proportion of green sea turtles greater than 357 pounds. All right, now to do that, the problem is I need to use normal CDF on my calculator. Normal CDF is a nice feature of the TI-84 calculator that can find proportions above, proportions below, or proportions in between. So I'm looking for a proportion above 357. The problem is, to do it, it only speaks in the language of z-scores. So I do have to come to the side here real quick and figure out what the z-score for a 357-pound turtle is. And it's a pretty easy formula. I'm just going to take the value of my individual turtle. I'm going to subtract the mean, and I'm going to divide by the standard deviation of 30. So I'm going to go to my calculator real quick here and do 357 minus 330, and then divide that by 30, and I get 0.9. The z-score is 0.9. So that means that this particular turtle is, that weighs 357 pounds is equivalent to being 0.9 standard deviations above the mean. So 0.9 is its position amongst all green sea turtles. So now I want to change my notation to looking for the proportion of z-scores greater than or equal to 0.9. The reason why I have to write that is because that's what my calculator is going to do to get the answer. And once again, the normal model does not distinguish between greater than or greater than equal to. So now that I know that I want to look for z-scores greater than 0.9, now I'm going to go to my calculator, second vars, and number 2 there is normal CDF. And I want to go 0.9 or higher. So I'm going to start at a lower bound of 0.9. And now I want to go infinitely high, right? Like I want to go all the way up. I want to look at all sea turtles greater than 357, greater than a standard deviation of 0.9. And to do that, I'm just going to do 99. Like we don't have an infinity button on our calculator, so we're just going to go to 99 to act like infinity. It's really, really, really high z-score, right? And all you got to do is hit paste and hit enter again to get the answer, and it's 0.1841. So that's how easy a problem like this could be. All right, let's do one more practice. What is the probability a green sea turtle weighs under 265 pounds? So this time we're going to notate what we're looking for. We're looking for the probability, percent, proportion, all the same thing, that a green sea turtle is less than under 265 pounds. Well, once again, my calculator's normal CDF feature doesn't understand pounds of sea turtles. It does understand z-scores though. So I'm going to come to the side here real quick, calculate the z-score for this particular turtle. Now 265 is below the mean, so I should definitely be getting a negative value here. So let's see, 265 minus 330. Make sure we hit enter to get the difference first, then divide that by the standard deviation, and I get negative 2.1667. Negative 2.1667. I always go 4 decimals for accuracy. All right, so now, whoa, what did I do there? I made a big mistake. That is not the answer. That's the z-score. That's not the answer I'm looking for. Sorry. Negative 2.1667. So now this question about green sea turtles being under 265 pounds is equivalent to z-scores being under negative 2.1667, right? That is how many standard deviations a 265-pound sea turtle is from the mean. All right, so now to answer that question, I'm going to go to grab normal CDF. I'm actually happy I made that mistake because a lot of people accidentally do what I did. They think the z-score is the answer, but it's just part of the answer. All right, now this time I'm going to start at negative 99 because I want to look way, way below. I want to look all the way down, and we don't have a negative infinity button, so we're going to do negative 99, and we're going to go to our z-score of negative 2.1667. All right, so this is going to give us the proportion of sea turtles that are below 265, which is the same thing as being below a z-score of negative 2.1667. And we get 0.0151. So very, very, very unlikely. 0.0151. Pretty unlikely that you would get a sea turtle like that. Most sea turtles are 330. That's where you're going to see the majority of sea turtles near. You're not going to see anything this low. You know, it's not impossible. Obviously, 1% chance is possible. It's just unlikely. All right, let's look at a slightly different problem, all involving the same concepts. All right, the weights of loggerhead sea turtles and other species of sea turtles also roughly follows a normal distribution with the mean of 365 pounds. So the mean is 75 pounds. 300, man, I cannot write today. 375 pounds. All right, so here's some information they tell us. They tell us that it is known that 45% of loggerhead sea turtles weigh over 400 pounds. I mean, I guess I could write that out, right? The proportion of loggerhead sea turtles that are over 400 pounds is 0.45. They're giving me that information free of charge. And then what they ask for is, what is the standard deviation? So how am I supposed to find that? Well, the only formula we know that involves standard deviation is the z-score formula. So I'm going to take that z-score formula. I'm going to write it down here. And I'm going to fill in everything I know. Well, the first thing I know is the mean. I know 375 pounds is the mean. And I'm going to leave the sigma blank because, well, not blank. I'm just going to leave it sigma because I don't know what it is. But I actually do know some other information. The other information they tell me is that 45% of loggerhead sea turtles are over 400 pounds. Now, that's X, 400 pounds, right? But the thing is, 45 is the proportion that are over 400 pounds. I need the z-score. Well, this is where my good friend Invert Norm comes in handy. So on your calculator, second vars, go down to number 3, Invert Norm. This is exactly what Invert Norm does. You type in the proportion, and it gives you the z-score that has that proportion. But here's the only trick. The area it's asking for is the proportion below. So I'm still focusing on a sea turtle that is 400 pounds. But the information they gave me was that there's 45% over, which means there's 55% under. So not only do I have to type it in as a decimal, I have to only type in the under. And again, if I give you the over, you just have to know that the calculator wants the under. So what Invert Norm is going to do is give me the z-score that represents a sea turtle with 45% over top of it or 55% underneath it. And we know that that is a 400-pound turtle. So that z-score is 0.1257. 0.1257. So again, I was given the mean, I was given a 400-pound sea turtle, and then I was given the proportion above that sea turtle. So I was able to use this information right here with Invert Norm to help me get the z-score I needed. Now I just have to solve. Multiply the sigma to the other side. 400 minus 375 is 25. And then all I have to do is divide. 25 divided by 0.1257. And this is going to get me my standard deviation. So 25 divided by 0.1257. And I get 198.8862. 198.8862 pounds is my standard deviation. All right, so what we did there was we worked backwards, right? If you go back to this slide, I gave you the weight. We found the z-score. We got the proportion. Well, here we're working backwards. I know the weight. I know the proportion. What I don't know is the z-score. So I'm literally working backwards. Proportion, and I'm working backwards to get the z-score. All right, so hopefully that made a lot of sense. All right, let's do one more that kind of combines everything. All right, giant leatherback sea turtles, a whole new species, have a weight that also closely follows a normal distribution with a mean of 1,025 pounds. Much bigger. These are huge turtles. All right, researchers have found that the proportion of leatherback sea turtles that are over 1,300 pounds is only 0.045. Let me write that down. The proportion of leatherback sea turtles that are over 1,300 pounds is equal to 0.045. All right, then the question they say is, what proportion of leatherback sea turtles are at most 750 pounds? So I really have to think about all the tools I have to answer this question. So they give me the mean, check. They give me this additional piece of information about 4.5% that are over 1,300 pounds. And then they ask me to find the proportion of leatherback sea turtles that are at most 750. Now be careful, at most means less than or equal to 750, right? At most means that that's the very highest or anything below it. All right, so here's what I'm thinking. To answer this question, this is a lot like the very first set of questions I asked you. I need the z-score. So the first thing I'm going to need is the z-score for this particular 750-pound turtle. And I already know the mean, but unfortunately, what I do not know is the standard deviation. So what I have to do is find the standard deviation first, which is what I taught you in the previous problem. So I kind of have to put a pause on this problem, right? I want to answer this question, but I kind of have to pause it for a second. And what I have to do is figure out how to answer this other thing where I need the standard deviation first. So let's use what we know to help do that, right? I know that a 1,300-pound leatherback sea turtle minus the mean divided by the standard deviation. Now, the one thing I know about this turtle is I already know that there is 4.5% or 0.045 above, right? So now what I'm going to do is I'm going to go back to my calculator and I'm going to use that information to get the z-score. So let's go once again to invert norm. And remember, though, the only thing is invert norm does the below. It wants the proportion below. So if there's 0.045 above, then there's 0.955 below. Hopefully you can do that math, right? 1 minus 4% is 0.96 minus the extra 0.005. So if you need a calculator to do that, go ahead. But if there's 0.045 above, there's 0.955 below. All right, so this is going to get me the z-score that I need here, 1.6954. 1.6954. So this is the z-score that represents a 1,300-pound turtle, which I know has 0.045 above it. All right, so I'm going to use all that information to help me set up this equation where I know almost everything except for sigma. So I'm going to multiply the sigma to the other side. And then 1,300 minus 1,025. Go ahead and do that math. 1,300 minus 1,025 is 275 divided by sigma. Oh, multiply the sigma over to the other side. Sorry, I think I said that, but I didn't do it. First thing we should do is multiply that sigma over to here. And then to solve for sigma, we're going to take that 275 and divide by the 1.6954. So 275 divided by 1.6954. And I get a standard deviation of 162.2036 pounds. 162.2630 pounds. I'm going to make sure I copied that right. 162.2036. Boy, oh boy, a little dyslexic. 2036. All right, so now that I know my standard deviation, I can now come over here and actually answer the question that they finally asked me. All right, they were asking me for the proportion of leatherback sea turtles that were less than 750. So the first thing I need to do is find the z-score. So now that I know the standard deviation, I can go ahead and fill it in here. And I'm going to go ahead and use as many decimals as I can. I mean, why not be accurate here? All right, so 750 minus 1,025. And then divide by the 162.2036. And I get a z-score of negative 1.6954. And now I'm going to find the proportion of z-scores that are below negative 1.6954. And when I go to my calculator to do that, I'm going to go and grab normal CDF, because remember, normal CDF finds proportions. I want to look below, so I'm going to do negative 99. I'm going to go way below, and my upper value is going to be my z-score, negative 1.6954. And this is going to look below. Now, be careful in the wording. A lot of kids mess it up. At most means below, right? At most means 750 or below. And I get 0.04499, which actually would round to 0.045. All right, so what do you think? A little bit more going on in this problem, but not too bad. Now, this problem is actually kind of a good one because I inadvertently noticed that we were looking at the top 4.5%, and then what we just found was the bottom 4.5%. And that was done on purpose to show you that the normal model is very symmetric, right? If you think about it, now this is not always going to happen, but in this particular problem it did, is because, 1,300 is 275 pounds above 1,025. and 750 is 275 pounds below 1,025. So basically, each value I gave you was very equal, the exact same distance from the mean, just above or below. So on the high end, that's going to put 4.5% above it. On the low end, that's going to be 4.5% below it. Now, again, that's not always going to happen, but I kind of made that happen on purpose here just so you can understand that the normal model is very symmetric. But at the end of the day, this is a great problem because it combines the two types of problems you have to do. You have to be able to answer a proportion question using normal CDF, but sometimes you might have to solve for the standard deviation first using some given information. All right, guys, hopefully this video helps, and it'll prepare you to do really well on anything I ask you in the future dealing with the normal model.